Hi everybody, let's talk about oceanic destructive plate boundaries. So what are destructive plate boundaries, especially oceanic ones? It's when two oceanic plates are moving into each other due to underlying converging convection currents. And one of them will subduct. Why? Because the plates would be older and therefore colder, so your materials are closer together and therefore it's denser and it will subduct. So let's draw it and visualize it on a diagram. Two oceanic plates, remember oceanic plates are thin, so you draw two thin ones. One here and one subducting, so one wants to touch it and then go downwards. Notice how I drew it really steep. That's because the oceanic plates, they are both really dense. One is denser and that's why one was subduct, but because they're both dense, this plate also wants to go down, also doesn't want to be pushed up. So it's really pressing down on the subducting area, and therefore it has a really steep subduction zone. So of course you draw your converging convection currents, and then you can draw your forces of the crust or the movements of the crust going towards each other. And because it's an oceanic plate or oceanic plates, then you might want to draw an ocean up here. You can label an ocean if you want. So you have landforms. These two are not really landforms, but you should know them. The Benioff zone is the point of contact between the two plates. It's defined as the zone of deep earthquake foci. So you have earthquakes happening because it's crashing into each other. So you have a lot of pressure created. And you have the subduction zone, which is over here. It's basically where your plate is subducting. Then you have the accretionary wedge or accretionary prism, whichever way is fine. Basically, when two plates collide, they will scrape off material off of each other, and this will cause a deposition of the material over here. And you can draw it as a slant or anything. You don't have to overcomplicate it. It's just an extension of that. But the most important thing is the ocean trench over here. The ocean trench is not the point at the subduction. It's actually the point between your accretionary wedge and your subducting plates. So over here, that is your ocean trench. And it's defined as a deep depression in the ocean, in the seafloor, often parallel to coast and stuff. Then you have volcanoes. Why volcanoes happen with oceanic plates? Because the materials that's subducting and therefore melting is really gaseous. You have silica, which is explosive and gaseous. So when it mixes with the material in the magma, when it melts over here, everything, most of the things will rise because it is less dense, it's gaseous, creating a magma chamber in the lithosphere in the crust, and therefore you have occasional eruptions upwards, and that builds up into volcanoes like this, and sometimes it can peak out into the sky. And when these happens, you have volcanic islands, and if there's a series of them, if there's a chain of them in an arc shape, it's called a volcanic island arcs. They are often parallel to the ocean trench. Now we move on to real life examples. The Marianas Trench is one of the perfect example of why an example of the steep subduction. You have the Pacific plate subducting under the Philippine Sea plate, and the Marianas Trench is 11,000 meters deep. I rounded it up a bit, and it's the deepest trench in the world because of the density issue. Then you have the Aleutian Islands, which is when the Pacific plate subducts under the North American plate around Alaska, and that creates your volcanic island arcs. And that sums it up about oceanic convergence or destructive plate boundaries, and I hope to see you in the next video.